Okay, we're going to have a look at this March 2022 one, which is using Pythagoras' theorem, determine the length of AC from figure 4. It's quite a straightforward question if you know how to do it. It does use simultaneous equations, which you don't really do for the rest of the course. So again, these are like miscellaneous questions. It is pretty neat, but it is a little bit complicated. And if your algebra is not so good, I really wouldn't recommend actually doing this question, except for if you're just going to rote learn it. Because if it does come up, it will come up exactly like this. I've seen it a few times. So yeah, it's like these little point grabs we can do towards the end of the course, worth doing about now, a few days before the exam. All right, so let's have a look at it. We've got two back-to-back triangles. I'm going to draw these triangles out. Let's get a bit more space, and we'll lay them out like we're going to have. I'll make them two different colors so we can see them really clearly. We'll have like a blue one over here, like that, and then we'll make a red one on the other side. So let's do that. And these guys are back to back, right? They're showing a common side. So I hope that's pretty obvious. And I'm going to split them apart so we can deal with them individually. And the base, they do actually say it's 2x on this first one over here, 2x. Okay, so this is going to be a 2x, and then this guy is just going to be an x. They say that this is root 13 centimeters, and this is root 10 centimeters. And then because they have this common side, I'm going to set both of these guys as y. And we're going to use Pythagoras' theorem. So obviously that's going to be a squared plus b squared is equal to c squared. So we're going to write that like a squared plus b squared is equal to c squared. I'm going to use it for both of them. Right, so I think I can move over here and we can just look at these guys now. And let's label up the sides of what's what. Okay, so the two short sides obviously are going to be the A and the B, so that can be these guys. That's the A, that's the B, and this longer side will be the C. That's going to be true in both cases. So let's do the same thing on this one. Let's say, it doesn't really matter, let's say this is the B, this is the A, and this is the C. Okay, as we got it all set up. So we're going to just plug in our values up here. So we said A is equal to 2x. So 2x, the whole thing squared like this. The B is going to be that y squared. I'm sorry, I wrote it backwards. It's a bit confusing. But we're trying to get the x's and y's out of this. And then the c squared is going to be root 13 squared. And that's really nice because it's going to cancel out. So all these square roots are actually going to disappear, which is really cool. Let's do the other side as well, because the other triangle, we're going to have a squared. That's going to be x squared. The b squared is y squared. And then that c, that's the c right there, is going to be this root 10 squared. So again, that's going to cancel out completely. And we're just going to be left with x squared plus y squared is equal to 10. Okay, I do have to handle both of these. I can do one and then the other, but I'm doing it at the same time, just to show you how to put it all together. All right, so then we're going to have to expand out this guy over here, and this is a little bit tricky, a little bit special. You got to, if you don't understand it or you can't see it very well, let's expand this out so you can see it a bit better. This is really saying 2x times by 2x. Okay, so we can multiply the 2's together to get 4, and the x times x will get me x squared, and everything else will just stay the same. So let's just write it out in neat. Okay, so now we're looking at these two equations right here. We got this one, which I suppose I could say is that's the blue one, because it came from the blue triangle, and this is the one, we'll call it the red one, because it came from the red triangle. Okay, and what we're going to do is try to fit these guys together. And this is what simultaneous equations are. You know some information about the first bit, some information about the second bit. You know they're related to each other, but you can't quite figure out. You got to figure out using logic about how to fit these guys together. So we're going to try to do that by rearranging these equations. So I'm going to take the blue one and let's just rearrange it so we get y squared by itself. So we're going to minus off this 4x squared from both sides. So we get 13 minus 4x squared like this. And then we're going to do the same thing with the red one. So this is going to be y squared minus, and then so I'm going to minus off this x squared from over here. So we get 10 minus x squared. Again, the reason why I'm doing this is because I'm trying to get these guys equal to each other to fit them into each other. And now you can see what's going to happen is that this is a y square, this is a y square. Because they're both equal to y square, we can actually fit them together. So let's say 13 minus 4x squared is equal to the 10 minus x squared. And that's the simultaneous equation bit. We're fitting these guys together. Finally, we can click them together like this. And now we can get to work solving this. This might not be the best way to do it, but I don't know. It's like easy. So we'll just go this way through it. Okay. Now we're going to get to work actually solving for the x. So I want to get this guy over to the other side so it becomes positive. And I'm also going to get rid of this 10. But let's do it two stages at once. So we got 13 two stages, one after the other, right? So I don't do everything all at once. This is going to become a plus on this side. So it becomes a plus 4x squared. That's wonderful because, 4x squared minus x squared will get me 3x squared. And then I'm going to minus off this 10. This is a plus 10. When I move it over here, it becomes a minus. So 13 minus 10 will be 3. Okay, great. So now we've got this kind of situation going on. We can divide both sides by 3. 1 is equal to x squared. We can square root this on both sides. We just get 1 is equal to x. Square root of 1. We're going to square it like this. It's going to cancel this out. And it's going to give us 1 is equal to x. You tend to get plus and minus x, but it's not valid for the negative values because we're talking about distances. So we don't count negatives when we talk about distances, which is a bit strange, but okay, we don't. So now we've got the value of x, which is nice, but the question wasn't asking that. The question was asking for determine the value of AC, which is this one in the middle. And that's not the x, that's our y value. So now we're going to go back and solve for one of these y's. And I got a nice little formula just tucked away in here somewhere that will give me either this blue one right here where it says y squared or this red one. I'm going to use this red one just because it looks a little bit easier. So I'm going to reference that, drag all this down, and now we know the value of x is equal to 1. I can plug it in here. So my y squared is equal to 10 minus 1 squared. 1 squared is just 1. 10 minus 1 is 9. So now y squared is equal to 9. If we square root both sides, we're going to get y is equal to 3. And that's what they're asking for. They're saying the length of the AC, and that's going to be the 3 centimeters. I could say AC is equal to that. But that's the length of the height of that triangle, which is what they're asking for.